You want to buy a car and a local bank will lend you $20,000. The loan will be fully amortized over 5 years, 60 months, and the nominal interest rate will be 12% with interest paid monthly. You should assume that this also means it's compounded monthly. What is the monthly loan payment and what is the loan's effective rate? So the way to understand this is a loan works the same way as an annuity. You have a lump sum that's equal to a series of equal payments that begin and end. So what's going to happen with this loan is you're going to borrow $20,000 today. That's the present value. And you're trying to find out what equal payment made every month for the next 5 years will pay off that loan. That is, what's going to balance the left-hand side with the right-hand side of the equation. We know what the nominal rate is, it's 12%. We know that the sub-periods are monthly, and we know that time is 5 years. So our annuity formula looks something like this, except where you have the payment or the coupon payment divided by n, because the coupon payment is viewed as being annual, and so we're getting the sub-periods. So where PMT is the annual payment, since we are interested in the monthly payment, we do not divide by n. That is, this would be the annual. If we were solving for the annual, we would need to multiply by n, but since we're solving for the monthly, we can drop dividing the payment by n here. And then all we need to do is to isolate for payment, which we're trying to find, is move this term, the annuity inflation factor, over to the left-hand side of the equation, that is divide it by, or divide into PV, and payment will be isolated. So we know that our present value is 20,000, the rate is 12%, sub-periods are 12, and T is equal to 5. We can do this the long way in Excel, where we say is equal to our present value divided by 1 minus 1 divided by 1 plus r divided by n to the power of t times n. Then we have to divide by r divided by n. And let's see, quick mistake here. There we go. Needed one more parenthesis. So we see that our monthly payment is going to be $444.88, maybe 89 cents. And that was simply by plugging values into this formula right here. The other way that's much more simple in Excel is just to use the payment function. So we'll say equal sign PMT. We'll reference the rate, but here Excel doesn't know that the rate is monthly, so we have to force it manually. So we're going to divide r by n, and then with the number of periods, t, we also have to force it that it turns out to be monthly, so that we actually have a total of 60 payments. The present value is the 20,000. And our future value can leave blank, and the type will leave blank by default. And so you see there that we also get $444.89. Next, we need to find what is the actual effective rate. So we'll be quoted a nominal rate of 12%, but because it's compounding monthly, we want to know what is the actual rate. So you guys know this formula here for the effective annual rate. And so all we need to do to set this up is equal sign 1 plus r divided by n to the power of n. That is, so we're capturing the number of periods in the month, or in the year, which is 12, and then we'll subtract 1. So we should expect a value just slightly higher than 12% because the compounding is monthly, so it shouldn't be all that large, but it should definitely be larger than 12%. And we find that the effective annual rate is 12.68%. So logically, this value makes a lot of sense for us. If we want to convert it to into a percentage, we can simply click and identify percentage. And so our effective annual rate is 12.63%. In Excel, you can also do =effective annual rate, but the other is simple enough, so we'll stick with it.